Bayaw. I'm here to give an example in fluid mechanics from Chapter 6, the fluid flow measurement. The water flows from A. Here the diameter is 10 inches to B, where the diameter is 24 inches at the rate of 12.5 cubic feet per second. The pressure head at A is 23.1 feet. Considering no loss of energy from A to B, find the pressure head at B. So this is the figure. Our solution. So this is the equation. Pressure at A over the density plus the velocity at A raised to 2 over 2g plus z at A is equal to pressure at B over density plus velocity at B raised to 2 over 2g plus z at B. So substitute. So we need first to find the velocity at A. So the formula to find is velocity at A is equal to volume flow rate over area at A. So equals to 12.5 cubic feet per second over pi times 10 inches. So inches, we need this to convert into feet. So 10 inches times 1 feet over 12 inches raised to 2 over 4. So simplify. So our velocity at A is equal to 22.92 feet per second. Second, find the velocity at B. So velocity at B is equal to volume flow rate over area at B. So 12.5 cubic feet per second over pi times 24 inches. So inches, we need this to convert into feet. So 24 inches times 1 feet over 12 inches raised to 2 over 4. Then simplify. So our velocity at B is equal to 3.98 feet per second. So 23.1 feet, which is the pressure head at A, plus 22.92 feet per second squared over 2 times 32.2 feet per squared second, which is the constant gravity, plus 12 feet, which is the height of Z at A, is equal to P at B over density, plus 3.98 feet per second raised to 2 over 2 times 32.2 feet over squared second, which is the constant gravity, plus 20 feet, which is the height at B. So, simplify. Our pressure head is equal to 23.01 feet.